Have you ever pondered the fundamental constituents of the universe? What makes up everything we perceive, touch, and interact with? Today, we're delving into the realm of atoms. Atoms, the universe's building blocks, are the smallest unit of matter that retains an element's properties, forming the basis of everything. They are many and varied, each associated with a unique element and defined by its atomic number and atomic mass. The atomic number equals the count of protons in an atom's nucleus, and the atomic mass is the sum of protons and neutrons. Elements range from lightweight hydrogen with 1 proton to the heavier uranium with 92 protons. The concept of atoms isn't new. It began with Greek philosopher Democritus, who postulated that everything is made of atomos, indivisible units. This was later expanded upon by John Dalton, who theorized that different elements combine in fixed ratios to form compounds. The atomic model evolved in the 20th century with Niels Bohr's work. Bohr proposed that electrons orbit the nucleus in specific energy levels, leading to quantum physics form our universe's essence. They are not only individual elements, but also combine to create molecules and compounds. This characteristic of atoms underpins chemical reactions and the diverse matter we see in nature. But how did these tiny particles originate? The story of atoms begins with the Big Bang. This cataclysmic event, which happened about 13.8 billion years ago, birthed our universe. After the Big Bang, the universe was a fiery, dense particle mix. As the universe expanded and cooled, these particles started fusing into atoms, primarily hydrogen-helium, marking the atomic era's start. From the air we breathe to the stars shining in the night sky, atoms form the essence of our universe. They not only exist as individual elements, but also bind to create molecules and compounds. This attribute of atoms is the backbone of chemical reactions and the diversity of matter we observe in the natural world. But how do atoms work? At the center of an atom, we find the nucleus, a dense core made up of protons and neutrons. Protons carry a positive electrical charge, while neutrons have no charge. Surrounding the nucleus in a cloud-like formation, we find electrons, particles with a negative charge. The number of protons in an atom determines the type of element it is. For example, a hydrogen atom has 1 proton, while a carbon atom has 6. The electron cloud plays a crucial role in how atoms interact with one another. These electrons occupy various energy levels, and it's the electrons in the outermost level that participate in chemical reactions. When atoms come together to form molecules, they're essentially sharing or exchanging these outer electrons. Atoms can also change through processes like radioactive decay, where an unstable atom loses energy by emitting radiation, or through fusion, where atoms combine to form a heavier atom, a process that powers the sun and stars. So, to summarize, atoms are the building blocks of the universe, born from the Big Bang. They're composed of a nucleus of protons and neutrons surrounded by a cloud of electrons. These electrons allow atoms to interact and form molecules, and changes in the atom's structure can lead to phenomena like radiation or fusion. In essence, understanding atoms allows us to understand the fabric of the universe. From the air we breathe to the stars we gaze upon, atoms are a fundamental part of our world. They are the silent architects, crafting the universe as we know it, one tiny particle at a time.